Hi everyone. Today I will talk about Pegasus spyware, and I will particularly focus on the forced entry exploit. It has been discovered recently. Some background information about Pegasus software. So it is developed by an SO group. This is a security company. They build software to sell it to the government to fight against the terrorists and crimes. So Pegasus, it was firstly discovered in 2016 on a human rights activist phone. And in 2018, the Citizen Lab published a report and identified 45 countries have used the Pegasus. In 2019, WhatsApp reviewed some victims that have been the target of the Pegasus. In the July 2021, journalists across the world have studied a Pegasus project, which reviewed some government user software to spy on the government officials, some politicians and journalists, and so many others. Pegasus uses a method called zero-click attack. So basically what it did is the attackers send some messages through SMS, WhatsApp, or iMessages to the target phone. So when the target devices rendering or processes content, the attacker takes advantage of the vulnerabilities in this devices, and then successfully attacked the phone, and then get all the user data from the user's phone and send it to the Pegasus server. So far, there are two types of exploits have been discovered and released to the public. The first one is called Kismet, and the second one is called forced entry exploit. And we will talk about it in detail. So how it works is, firstly, the attackers send some messages to the target. The victim phone will receive many push notifications and some attachments. After the attachments were written to the disk, the device started to process those attachments, and then it crashed. And finally, we noticed the exploitation succeeded. This image shows a sample of the files that found in the victim's file systems. So those files with .gif extensions were sent immediately before the victim's phone was hacked. According to the report from Citizen Lab, when the forced entry exploit was being fired at a device, the device logs showed crashes. Looking at the crashes and the red box 1, we noticed that the crashes is inside the IM transcoder agent. And all these crashes started off by calling the functions within the library called core graphics. So here comes our two questions. The first one is, so what is IM transcoder agent? The second question is, so what actually happened inside the core graphic function? Answer the first question, what is IM transcoder agent? The IM transcoder agent is actually inside the blast door security system. This system was developed by Apple to actually prevent the previous zero-click attack, but obviously it failed this time. So it takes the incoming messages and process their content inside a secure and isolated environment. And IM transcoder agent is used to transcode and preview the images sent through the iMessage. So basically, it gets crashed when it processes the images the .gif file that we saw in the previous slide. So what actually happened inside the core graphic library is within the function called read text region set. So we can dive deep into this code. In the red box, the program calculates alpha integer value called nonsims. So in line 5, we can see that it got incremented by the size of the JBig2 symbol dict. The getSize function actually returns a value that's also unsigned integer. So this will cause an integer overflow issue, which means the nonsims could be actually smaller than the total size of the JBig2 symbol dict. And then in the blue box, the program allocated some memories based on the nonsims value we calculated before. And then in the yellow box, the program fills the buffer. It's allocated before with the value from the bitmap. And we noted that in this for loop, we can see that it's actually dependent on the JBig2 segment size, which we discussed before. It actually could be larger than the buffer we allocated. And then this leads to the out of bound write access to the device's memories. So this is actually a classic buffer overflow attack. It allows the attacker to introduce or write malicious code into the device's memories, and then it can execute the code in the context of the current process. After crashes, after the IAM transcoder agent crashes, we notice the Apple thermal monitoring system, thermal monitor, return a series of errors, and then it invoked a process called tailspin, and that process running alongside the spyware. So we saw that false entry successfully exploited and deployed against iOS system. So one thing to notice here is this IAM transcoder crash is only the starting point of the attack. There are some other methods Pegasus took to bypass some other security checks in the iOS system. And that part hasn't been released to the public. And we look forward Citizen Lab can review more detailed information about that part in the future. So Apple has already fixed this problem. We can take a look at what happened here. So when the function is copying value from the bitmap to the heap buffer, Apple added a variable called KK, and then it added two boundary check. We can see it's inside the red box. So these two boundary checks will help to avoid the overflowing from the sims buffer. Here's two questions I have for you guys today. The first one is, how does the fourth entry get around the blast door security system? And the second question is, what fix did Apple implement and why it works? Thank you for listening.